the next section of that, I guess, inquiry question is also how it looks like in the periodic table, and I'm also combining it with the third inquiry question of periodicity. So, and that's pretty much just asking, what are the patterns in your periodic table? For those who may think that you can, I feel like try memorizing the periodic table. You don't need to memorize the entire one. You're given it to it in the exam. It's not worth it. And if you're never given a periodic table, ask for one because you're meant to be given one anyways. And I feel like for the periodic table, all you need to do is just know where things are in terms of the elements. And in terms of using the periodic table, they may look confusing, complex, and even annoying, but they're actually really, really useful. And you pretty much need them to do the calculations anyways. So yeah, they're really important. If we just break down on how we read periodic tables, we always start off with, there's like a few different elements. You have your, written representation or name. And you also have a symbol to represent it. For carbon, it's C, so pretty straightforward. Sometimes, for example, like sodium doesn't have S, it has Na because that comes, I think, from its Latin name, natrium. So you may also see the Latin, I guess, symbol as well. And you also have something called an atomic number at the top over here that's above the symbol, and this is pretty much the amount of protons that is in the nucleus. And then you also have something called the relative atomic mass over here. So that's pretty much the mass of the nucleus that you have in your specific atom. And a nucleus contains both protons and neutrons. Sometimes the name isn't included, unfortunately, so just you just kind of got to know what is what. But if we look at not Chemist Warehouse. If I look at the periodic table that we have over here, if I just rotate this, this is the HSC periodic table. They've given you the names, which is good, as well. So if you ever forget what the symbol stands for, you can always look at the name underneath. So I recommend that you just print this out and have this next to you whenever you're doing practice problems, because you want to get familiarized with what this periodic table shows you. So let's go back to our slideshow. And the periodic table pretty much looks like this. Technically, you have 18 groups. We mainly only look at these ones over here, not anything from 4 to 12 over here, because they're really just transition metals. And they tend to have varying charges. So it's not really good for predicting trends. And these are lanthanoids and actinoids. You don't really encounter these ones, except really uranium maybe. But for the rest, you kind of just have to know what is what, I guess. So for example, these are your alkali metals and these are your alkaline earth metals. You have your transition metals over here. You also have a bunch of other metals over here. They're not really categorized. And these are your nonmetals. But if we want to further specify what they are, this group 7, is halogens, and this is group 8, which is your noble gases. Noble gases are stable. They don't react with anything. And yeah, you don't really need to worry about whatever I'm crossing out over here. But for the rest, you need to know these by heart. You've got to know the charges, what they are, where you can kind of find them on the periodic table. Don't bother about memorizing the atomic mass or anything like that. They'll usually give it to you in the periodic table anyways. Overall, in terms of what the periodic table are, groups over here are the vertical columns, and periods over here are your horizontal, I guess, like rows that you see over here. Groups tend to have similar characteristics. Rows don't, or periods don't, sorry. Groups tend to be characterized by their charges. So these have a +1 charge. This is +2, +3, +4, -3, -2, -1, and 0 as a charge. That's how you kind of structure it. And that's how you kind of know what they're representing. And the main ones that we're really concerned about is alkali or alkali earth metals, transition metals, halogens, and noble gases. Metals, in terms of their characteristics, tend to be shiny, ductile, malleable. They have a good melting and boiling point. Metalloids have similar characteristics of both metals and non-metals, and gases, which are typically non-metals anyways, they are dull. Sometimes you're not being able to see a color. You may be seeing a color for gases, and they have a lower melting and boiling point, and they do not conduct heat or electricity that well. For the rest of them, you have alkali and alkali earth metals. These tend to be really soft and highly reactive. Halogens tend to exist in pairs, and noble gases are single atoms. They are colorless, and they don't really react with anything. And transition metals, everything's different. They just have different properties. So it just depends on the element that you have over there.